Have you ever heard someone say that a ship is moving at 20 knots? Or a plane is cruising at 480 knots and wondered why they aren't using miles per hour like we do on the road? It might seem strange at first, but the story behind knots is one of human ingenuity, survival, and centuries of navigation history. Today, we're going to unravel the mystery behind this seemingly simple term and why it's still used by sailors and aviators alike. If you're serious about understanding the little details that shape our world, make sure you hit subscribe and join our community of curious minds. The challenge sailors faced before modern navigation. Long before GPS, radar, or electronic instruments existed, sailors had a serious problem. How could they know how fast their ship was moving across the vast open ocean? Speed wasn't just a number, it was essential for survival. Without a reliable measure of speed, plotting a course to a distant destination was a guessing game. A small miscalculation could mean running out of food, missing safe harbour, or drifting into dangerous waters. In the early days of seafaring, navigation relied heavily on the stars, the sun, and compasses. But without knowing the ship's speed, even the most skilled navigator couldn't accurately calculate how far they had travelled. Understanding speed was just as crucial as understanding direction. Yet, sailors had none of the tools we take for granted today. How sailors turned a simple rope into a precision instrument. Faced with this problem, sailors developed a remarkably simple yet effective tool known as the log line. The log line was a long rope with knots tied at regular intervals. One end was attached to a piece of wood, usually a flat quarter-circle board designed to act as a drag when thrown overboard. As the ship moved forward, the rope would unravel, and sailors would count the knots that passed through their hands over a set period, often measured with a sandglass. The number of knots counted in that time directly corresponded to the ship's speed. This practical approach didn't require clocks, electronics, or complex calculations. Each knot on the rope represented a measurement of speed. If a sailor reported the ship moving at 10 knots, it meant that 10 knots of rope had passed through their hands within the timing interval, giving an accurate representation of velocity. This method, while basic, was ingenious. It allowed sailors to quantify speed with nothing more than rope, a wooden board, and a sense of timing. It's a reminder that some of the most enduring solutions in history came from simplicity and resourcefulness. The spacing of knots on a log line wasn't arbitrary. Knots were tied about 47 feet, 3 inches apart. That number might seem oddly specific, but it was based on a combination of the rope's length and the timing of a 28-second sandglass, which was the standard at the time. This precise measurement ensured that each knot roughly equaled 1 nautical mile per hour. If, during a 28-second interval, 7 knots passed through a sailor's hands, it meant the ship was travelling at 7 nautical miles per hour. Over time, sailors simply started saying 7 knots rather than describing the timing and rope. The terminology stuck, becoming a part of maritime culture that endured even as technology advanced. What's fascinating is that this method was both practical and accurate enough to guide explorers safely across the world's oceans. It highlights how necessity drives innovation, and how a simple rope and some knots could have such a profound impact on navigation. To fully understand why knots persist today, it's important to grasp what a nautical mile actually represents. Unlike a standard mile, which is a unit of land-based measurement, a nautical mile is tied directly to the geometry of the Earth. 1 nautical mile equals 1 minute of latitude along any meridian, which translates to approximately 1.852 kilometers or about 1.1508 miles. This system makes plotting courses on the globe far more logical. Using nautical miles allows navigators to measure distance and speed in a way that corresponds directly to geographic coordinates and the Earth's curvature. That's why knots remain the standard. 1 knot equals 1 nautical mile per hour, which really simplifies calculations when plotting courses across oceans or through airspace. Even as mechanical tools evolved, including the invention of chip logs and patent logs with propellers that measured water flow, the measurement unit never changed. Knots had become too deeply embedded in navigation traditions to be replaced. Why pilots also use knots? Knots aren't just a maritime relic, they are the standard in aviation as well. Air navigation relies on the same principles as maritime navigation. Distances are measured in nautical miles because air routes often follow geographic coordinates rather than straight lines across land. Aviation professionals measure airspeed in knots because it aligns with nautical miles, simplifying calculations for fuel consumption, travel time and distance. Whether flying over the Atlantic or across the Pacific, speed in knots allows pilots to integrate navigation with the same logic that sailors have relied on for centuries. This is a perfect example of how a centuries-old invention, born from necessity, continues to influence modern technology. Knots provide consistency across different environments and ensure that navigation, whether on water or in the air, remains accurate and reliable. Knots carry history as well as practical meaning. Beyond mathematics and navigation, knots have a story to tell. Each knot, counted by a sailor, represented progress, persistence, and human curiosity. They weren't just numbers, they symbolized exploration, risk, and the steady pursuit of knowledge across the world's oceans. Even today, modern instruments and satellites measure speed digitally, but the knot remains a tribute to those early explorers. You know, it reminds us that some of the most effective solutions are born from simplicity and ingenuity. When a ship sails at 15 knots or a plane cruises at 480 knots, it's not just a measurement, it's a continuation of a centuries-old tradition. The beauty of knots lies in their enduring relevance. What started as a rope tossed into the ocean has persisted into the digital age. These days, modern ships and aircraft rely on advanced sensors, satellite positioning, and automated systems, yet the unit of speed remains the same. It's really a testament to human innovation. A simple idea, once proven effective, can stand the test of time. For those of us fascinated by how everyday systems came to be, knots offer a perfect example of history, science, and practicality intersecting. Understanding why we use knots instead of miles per hour gives insight into navigation, exploration, and the subtle ways past ingenuity shapes our modern world. Knowing about knots isn't just trivia. It's a lens into how humans have solved complex problems with creativity. It teaches us that innovation doesn't always come from complicated tools. Sometimes it comes from observing, experimenting, and making the most of what you have. For anyone interested in navigation, history, or the practical origins of everyday terms, understanding knots connects you directly to centuries of human problem-solving. The next time you hear a speed in knots, you'll know the story behind it. Sailors counting knots on a rope, explorers navigating uncharted waters, and the enduring logic of nautical miles. If you've enjoyed learning the story behind knots and want to keep uncovering the hidden histories behind simple things, make sure to subscribe so you won't miss our next exploration. And if this video gave you new insight, share it with a friend who loves learning the secrets behind the ordinary. Understanding something as basic as a unit of speed can open a window into the extraordinary world of human ingenuity. And that's exactly what we're here to do.